So today we're going to start, we call it chapter 5, but I mean really for you it's just the next section because we don't use our textbooks anymore, but this is the old section 5.1 out of the textbook. So calendar has been updated, so we're going to have a formative next week, Tuesday. And then we're going to have a test in 2 weeks. Good God, it's February already on Saturday. Good Lord. You know what that means, Claire?
1 month closer to getting out of here.
Yep, exactly. Okay. All right. So, just so you know, there's that. That has not been updated because the test is not on Friday, January. This is all kinds of goofy. Probably should have hit save when I did this last time. So we'll hit save now. These are your grading mods, just as an FYI. Okay? So you are all now LINS 10 through 12ers. Okay? The most important part of that is the LINS part. Okay? I don't really care about your actual grading mods. Just make sure when you're turning stuff in now that you turn it into MyBasket. Okay? Great. All right, let's do this. So it's a new chapter. Okay? And what do we have to look forward to now? This is we've been using this script for a while now because it just sounds cool. Okay? In this chapter, we will shift our emphasis more towards theory and proof, exploring where the properties of these special trig functions lead us, often with no immediate concern for the real world relevance at all. What I mean by that, Dylan, is you're going to ask me at some point in time in the next 2 weeks, LINS, where in the heck am I going to use this? And I'm going to say, you're not. Right to your face. Okay? You're not. Okay? But it's not about where you're going to use this. It's about using properties, appreciating the rich and intricate tapestry of interlocking patterns that can be woven from the 6 basic trigonometric functions. Okay? Patterns that will take on an even greater beauty later on when you see them through the lens of trigonometry. So that's what we're going to do. We're going to start this unit, or today, we're going to start with what's called identities. Okay? So we're going to work out some identities for you today. Later on, we're going to give you, I'll show you an example of it because I'm changing it around. We're going to give you an identity sheet. So these are the 26 identities that we're going to learn in this chapter. Okay? That's a lot. So we give you this sheet. Okay? The only reason that we didn't give you this sheet today is because we said we're going to put the unit circle, a big old unit circle on the back side. We haven't done that yet. And by we, of course, we know who I'm talking. No. This one's not a schnout. This one's a B. Okay? So we're going to do that. Okay? So, the 6 basic trigonometric functions. Cosine is cosine. Okay? Sine is sine. Okay? We know that. Okay? Secant is the reciprocal, not inverse. Okay? Like some people did on their test. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. Okay? Tangent is sine divided by cosine, and cotangent is cosine divided by sine. Okay? Right? And then, of course, we've got our big one. We've got the hammer. Sine squared plus cosine squared is 1. Right? But what that also means is, that sine squared is 1 minus cosine squared. If I subtract cosine squared from both sides. That also means that cosine squared is 1 minus sine squared. If I subtracted sine squared from both sides of the hand. Okay? Any questions on those so far? Okay. So let's take the hammer. Sine squared plus cosine squared equals 1. And let's divide both sides by sine squared. Now, if I divide both sides by sine squared, what I'm really doing is I am dividing each and every term by sine squared of theta. Agree? Mathematically legal. Yay or nay? Meaning, am I using good math? Yeah. Because we're dividing it everywhere, it's good math. Okay? Well, what's sine squared divided by sine squared? 1. What's cosine squared divided by sine squared? Tangent squared? Be cotangent, right? Because tangent was sine over cosine. Cotangent is cosine over sine. So this is cotangent squared. Okay? What's 1 divided by sine squared? Which one? Cosecant. Just straight up cosecant? Or cosecant squared, because it's sine squared. Yep. So that is also an identity, which you could also change into right? Which you could also change into with me? Okay. Let's go back to the hammer. And now this time, let's divide by cosine squared. My math good so far? Math good so far? Okay, all right. Sine squared divided by cosine squared. That's tangent squared. Cosine squared divided by cosine squared. That's 1. 1 divided by cosine squared. Secant squared of theta. Yep. That's another identity that we get out of the hammer, which could also be written as Agree? What's up, James?
These are all identities, so it'll be in the GPU, right?
Yes and no.
Okay.
We only put this one on there. We only put the top one on there. On both of those. Okay. So let's simplify. That's what we're going to be doing. We're going to be simplifying first here in section 5.1, and then in section 5.2 next week, we're going to be proving trig identities. We're also going to be solving a little bit later on this week too. Okay? So way back from the hammer, we learned that, I shouldn't say from the hammer, from the obviosities, we learned that the sine of a negative angle, so if we're going negative angle, then the sine is opposite. Right? Okay. We also learned that the cosine of a negative angle is the same. Which means tangent would be opposite then. Since they're both not opposite, it's tangent's opposite then. Okay? Those apply to cosecant, secant, and cotangent also. Okay? So this is really negative secant of x. Oh, tap the brakes. Secant goes with cosine. That's really just that, because secant goes with cosine. This oops, I shouldn't use blue, because I used blue down here in the pre-member. This is just that, right? Secant is also what? It's what? 1 over cosine, right? One over cosine of x times cosine of x is cosine of x over cosine of x, right? Which is 1. We'll get later on, I'm just going to fast forward here for you, we'll get later on some ugly looking things. And that might simplify down to just be sine. You know what I mean? That's where we're getting to. We're gonna create a bunch of identities on our own. Okay? Now, in number 2 here, I'm going to do that one in 2 different ways. Okay? Meaning, if I choose to deal with secant squared, okay? Anytime you see a squared, you should automatically think back to either this one, or the hammer. Okay? Anytime that you see a squared, automatically that should be your ding-a-ling-a-ling saying, okay, I've got secant squared. Secant squared is the same as tangent squared plus 1. So if I take this here, then that becomes tangent squared of x plus 1. And then I still have this minus tangent squared. With me so far? If I combine like terms, what's tangent squared of x plus 1 minus tangent squared of x? Just 1. Because the tangent squared minus tangent squared makes it go away. So this simplifies to also just be 1. Now, if I didn't do it that way, if I went with secant squared, and I readjusted the tangent squared. So now tangent squared is secant squared minus 1. This bottom version of that identity. So then that's going to be that, correct? Well, if I distribute that negative sign in there, I get that. Secant squared plus secant squared minus secant squared goes away, and then I get my 1 that way. Okay. Many different ways. I will use the analogy to go from here to Mosinee. There's many different ways that you could go. Okay? You could get on 51 and just head right there. Okay? You could get on 51, but then get off and take what goes past the school forest? Is that X? K. You take K in there. Okay? You could go out to Marathon City and then cut down 107 and cut back in on 153. Okay? Truthfully, you could go up to Merrill. Okay? I've seen it happen before. You could go completely the wrong way, but still end up there. Okay? By taking some different paths. It's not up to you to determine which path is right. It's up to me to determine if the logic behind your path is logical. Okay? You got to use the identities that were given. I got to make sure you're using them the right way. Okay? Right? Because there's more than one way to do these. Oops, nope, number 3 there. Okay? You try these 2. Unpause it first. There we go. Now it's unpaused. All right. So cosine is cosine. What's tangent? What's sine over cosine? So then this would just be sine of x. Agree? Yes? Yeah. Okay. Secant is 1 over cosine. It's going to help you to remember that everything needs a co. Okay. Cotangent is cosine over sine. So then this becomes 1 over sine, yes, which is cosecant. Okay? Try those two. Cosecant is 1 over sine. Distributing in the sine of theta gives me sine over sine is 1. Sine times sine is sine squared of theta. Hammer was sine squared plus cosine squared equals 1. So that means then that 1 minus sine squared is cosine squared. One minus cosine squared, based off of the hammer, is sine squared. Cosecant is 1 over sine. So this becomes sine squared over sine, which simplifies just to be sine of x. Questions, comments, concerns, clarifications? Try those two. I get cotangent of theta for number 7. Yes? Yeah. Tangent squared plus 1 is secant squared. Cosine squared is just cosine squared. Secant is 1 over cosine, so secant squared is 1 over cosine squared. Cosine squared divided by cosine squared is just 1. One more. Now, when we've got adding and subtracting in it, we can't just switch around everything. And we might have to factor. Can I factor something from this? Something that shows up in both terms. X is the angle, so I can't factor out an x. No. Sine x I can factor out, though, because sine shows up in both of them. So then this is going to become sine x out in front. What's left over? 1 minus cosine squared. Can I do anything with 1 minus cosine squared? It's sine squared? Yep, I would agree that that is sine squared. Sine times sine squared. Sine cubed. Yep. If you'll notice in the homework packet that you picked up, we stepped up our game, and that it is now 1 through 43. Okay, so they're all the numbering system goes. It starts with number 1, and all of the individual problems go all the way through. As of right now, you can do numbers 1 through 12, with the exception of 5 and 6. So you can do 1 through 12 with the exception of 5 and 6.